The skills that got you hired aren't the same skills that will get you promoted. What actually makes someone a senior data scientist? Junior data scientists focus on the technical work, whereas senior data scientists focus on the business impact enabled by the technical work. It's moving from I do what I'm told to do to I solve problems that matter. The data scientists who master them become not just senior individual contributors, they become the leaders who shape how their organizations use data to create value. Hey there, welcome to Data Science or Not. I'm Terry. If you've been grinding away as a data scientist for a while, you've probably noticed something frustrating. The skills that got you hired aren't the same skills that will get you promoted. Despite perfecting SQL queries, mastering data analysis skills, and implementing cutting-edge algorithms, you might still be stuck in that junior or mid-level position. Meanwhile, others advance ahead of you. I've been there. 8 years ago, I was that confused data scientist, wondering why my technically brilliant work wasn't getting recognition. Today, I want to share what I wish someone told me back then. In 2025, the path to becoming a senior data scientist is more confusing than ever. AI tools are automating many technical tasks. Organizational priorities keep shifting. Role definitions are blurring. The question becomes, what actually makes someone a senior data scientist? Through my own journey and observing hundreds of data scientists across companies, I've identified 3 critical shifts. These shifts separate those who advance from those who stagnate. These are the real unwritten rules of career progression that no one tells you about until you've learned them the hard way. Let's dive in. Let me tell you about a humbling moment from my early career. 12 months in, I was our team's technical star. I had notebooks of optimization techniques. I could squeeze extra percentage points of performance from any model. During the promotion discussion, I proudly presented my technical achievements. I was so certain that I checked all the boxes for senior level. My manager's response? Terry, I can tell you're proud of these incremental improvements, but I can't explain to partners how any of these moved our client businesses. Senior data scientists don't just build better models. They solve meaningful business problems. That truth hit hard. I had spent months improving model metrics that basically nobody outside of our immediate team cared about. This mindset shift is the first invisible barrier to advancement. We must move from optimizing technical metrics to driving business outcomes. It's especially challenging because most of our training reinforces the opposite. Here's what this shift looks like in practice. The junior approach. I improved a model AUC from 0.82 to 0.86 by implementing sophisticated feature engineering and conducting a comprehensive grid search. The senior approach. I identified that a 3% improvement in prediction accuracy would reduce customer acquisition cost by about $500,000 per quarter. Working with marketing, we prioritized top 3 features that would give us the biggest gains for the least complexity. Our deployed solution is currently on track to exceed our acquisition target. The difference is subtle but crucial. Junior data scientists focus on the technical work, whereas senior data scientists focus on the business impact enabled by the technical work. I've seen this pattern repeatedly across organizations. My colleague Jamie remained at mid-level for years despite being technically brilliant. His project updates focused exclusively on model improvements. Meanwhile, Lynn was promoted twice in 18 months despite having less technical depth. She consistently framed her work in terms of user engagement improvements and revenue impact. So, how can you make this shift? Start by, number 1, setting business-aligned goals for your projects. Before any analysis or modeling work, define how success will be measured in business terms. Number 2, learn your company's business model inside out. Understand the revenue streams, cost structures, and the metrics that the leadership cares about. Number 3, following your models into production. Don't consider your job done when the model is built and handed over to engineering. Track how it actually performs in the real world and how it influences business outcomes. Number 4, speaking the language of stakeholders. When communicating with product managers or executives, lead with business metrics, not technical details. Number 5, building metric translation skills. Be able to explain how changes in prediction, recall, or other technical metrics translate to dollars, user engagement, or other business outcomes. This mindset shift doesn't mean abandoning technical excellence. It means channeling your technical expertise towards problems with meaningful business impact. It means communicating your work in terms that resonate beyond the data science team. When I was working on a user segmentation project early in my career, I spent weeks on sophisticated clustering algorithm. It even incorporated natural language processing on user reviews. I was very proud of my elegant, complex solution until my manager asked me to explain it to the sales team. As I struggled to convey the nuances, watching eyes glaze over around the room, a senior colleague interjected. Couldn't we just group users by their purchase frequency and average order value for now? That would give us 80% of the insight with 20% of the complexity. He was right. My solution was technically impressive, but practically painful. It would have been difficult to explain, implement, and maintain, especially if it is going to be used by the non-technical sales team. I had fallen into a common trap, equating complexity with value. This leads to the second critical shift, moving from pursuing technical sophistication to delivering right-sized solutions. Senior data scientists understand that often the best solution isn't the most advanced one. It's the one that solves the problem adequately with appropriate complexity. Here's how this mindset difference manifests. The junior approach. For this classification problem, I implemented a stacked ensemble of 3 gradient boosting algorithms with a neural network meta-learner to maximize our F1 score. In the senior approach, I tested 3 approaches of increasing complexity for this problem. A logistic regression with 5 key features achieved 90% of our target performance with minimal complexity. We implemented that first to get quick wins while evaluating whether more sophisticated approaches are justified. The shift is particularly difficult because our education and online resources really emphasize cutting-edge techniques. We are rewarded in school and interviews for knowing the latest algorithms. But in practice, companies value solutions that are maintainable, interpretable, and proportional to the problem's importance. So how can you develop the sense of appropriate complexity? Number 1, always start simple. For any new problem, implement the simplest possible solution first as a baseline. You'd be surprised how often it's sufficient. Number 2, quantify the trade-offs. When considering more complex approaches, explicitly calculate the cost versus the benefit. Consider time, complexity, and maintainability against your performance gains. Number 3, consider the full life cycle. Remember that someone will need to explain, debug, and maintain that solution. Factor that into your decision making. And number 4, build a complexity/impact framework. For each project, plot potential approaches on a matrix of complexity versus business impact. Aim for the high impact, appropriate complexity quadrant. One of my most valuable career experiences was inheriting a complex deep learning system. No one could maintain it after the original developer left. Despite its theoretical performance advantages, it was so sophisticated that it required constant monitoring. It frequently failed in production. I learned more about appropriate complexity from that maintenance nightmare than from any successful project. Remember, your job isn't to build the most sophisticated system possible. It's to solve problems effectively with the appropriate tools, and senior data scientists are valued for their judgment in selecting the right approach. The final and perhaps the most significant shift involves how you define your scope of responsibility. It's moving from I do what I'm told to do to I solve problems that matter. In my second role, I was asked to analyze why our conversion rates were below target. I interpreted this as run the numbers and create a dashboard for us to track it. I spent weeks slicing the data by every dimension I could think of. I created beautiful visualizations and delivered a comprehensive report and considered my work complete. 2 months later, during a strategy meeting, the conversion rates were still below the target. My manager asked what actions had been taken based on my analysis. The room went quiet. Despite my thorough analysis, nothing had actually changed. Why? Because I had focused narrowly on the analysis task. I hadn't facilitated any discussions about what the data actually meant. I hadn't proposed specific actions. And I hadn't followed up to ensure the changes were implemented. I had executed my tasks perfectly, but failed to solve the actual problem. This is the essence of the ownership evolution. You must expand your sphere of responsibility from executing your assigned tasks to truly owning the solution of meaningful problems. Senior data scientists don't wait for perfectly scoped tasks. They identify problems that are worth solving and take ownership of driving that solution. Here's what this looks like in practice. The junior approach. I was asked to analyze the drop in our trial conversions. So I created a detailed report breaking down conversion rates by user segments, traffic source, and device type. I shared the report with the team. The senior approach. When I noticed our trial conversations dropping, I analyzed patterns across segments and identified a significant issue with the mobile checkout flow. I then worked with a user experience team to design A/B tests for 3 potential solutions. By analyzing the experiments, the winning design improved the conversions by 18%. We're now standardizing this process across all our checkout experiences. The difference? A task executor delivers analysis and reports. A problem solver identifies root causes, collaborates on solutions, and drives measurable improvements. So, how can you make this shift? Number 1, reframe assignments as problems to solve. When given a task, ask, what is the underlying problem we're trying to solve? What would a comprehensive solution look like? Number 2, adopt a end-to-end thinking. Consider the entire life cycle of your solution. Think from the data collection to insights to action and the measurement of your action. Number 3, build cross-functional relationships. Solving these complex problems requires working effectively with product, engineering, design, and business teams. Invest in all of these relationships. Number 4, develop your stakeholder management skills. Learn to identify who are the key decision makers, understand their priorities, and then build consensus for your proposed solution. That's the way to get things done. And number 5 is to track outcomes, not outputs. Measure your success by the real-world impact of your work. Don't focus on just completing the analysis or delivering the reports. My colleague Alex embodied this approach perfectly when she was addressing our underperforming marketing campaigns. Rather than simply running the requested A/B analysis, she interviewed the stakeholders to understand their hypothesis and what decisions they needed to make. She expanded the analysis to include customer journey data that wasn't originally requested. She identified a critical insight that our targeting was fine, but our message timing was off. She then proposed and organized a cross-functional workshop to redesign the campaign sequencing. And then she created a measurement framework and personally tracked results for the first month. The outcome wasn't just a completed analysis. Her approach led to a 32% improvement in marketing efficiency and clearly demonstrated she was operating at a senior level. This ultimately led to a promotion. This problem ownership mindset manifests in practical behaviors. You speak in terms of problems to solve rather than tasks to complete. You proactively communicate updates rather than waiting to be asked. You anticipate potential issues before they arise. You think across organizational boundaries rather than staying in your lane. You take responsibility for your outcomes, not just following the right process. The shift from "I completed my assigned analysis" to "I ensured our business problem was solved" is the essence of advancing to a senior role. It's about expanding your sphere of influence and responsibility beyond your immediate technical work. So, how do you actually make these shifts happen? Here are concrete steps you can take, starting today. Number 1, learn the business. Identify someone who can help you understand how your company makes money. Look for a product manager, FP&A manager, or a business-savvy engineer. Get them coffee and ask questions. Number 2, create a project checklist. Before starting any new work, document: what business problems are we solving? Who are the stakeholders? What does success look like in the business terms? And what's the simplest approach that might work? And number 3, shadow senior data scientists. Observe how they communicate in meetings. Watch how they scope projects and make technical decisions. Note the difference in how they approach problems compared to more junior members. Number 4, start small with ownership. Identify a minor pain point or an opportunity that's currently under-addressed. Take an initiative to solve it. This builds your problem-solving muscle in a lower-risk context. And number 5, seek feedback on your communication. Ask your trusted colleagues: when I explain my work, is it clear how it connects to business goals? Am I using the right language for my audience? These practical steps will help you internalize the mindsets that define senior data scientists. The journey from junior to senior data scientists isn't primarily about technical knowledge. It's about mindset shifts that change how you approach and deliver your work. From optimizing model metrics to driving business outcomes. From pursuing technical sophistication to delivering right-sized solutions. And from executing tasks to solving meaningful problems. These shifts don't happen overnight. They require intentional practice, reflection, and sometimes learning the hard way, as I certainly did. But they are far more predictive of career advancement rather than any particular technical skill or certification. Remember, tools and technologies in data science will continue to evolve, but these fundamental mindsets remain constant. The data scientists who master them become not just senior individual contributors, they become the leaders who shape how their organizations use data to create value. I hope these insights give you a clear path forward in your own career journey. If they've been helpful, or if you have your own wisdom to share, please drop a comment below. And don't forget to subscribe for more real talk about data science careers. I'm Terry, and I'll see you in the next one.